Welcome, junior mathematicians. Today we are going on a trek to a country called Indonesia, where we will travel through hot terrain in search of a nature phenomenon. Passports aren't needed, only an open mind for exploring, experimenting and learning. In order for you to conquer this mission, you'll need to pair up with a travel buddy and keep a journal of your experience. Pens up, eyes and ears ready for phase 1 of our mission. Your mission is to help identify the nature phenomenon by conquering the battle of the words, which is linked to Indonesia and measurements. One word will be left in order to unlock Indonesia's natural phenomenon. Battle stations. Please read carefully as you will learn a bit about the country and the phenomenon. Remember that the words in red are the words you need to find in the battle of the words. Good luck! There are many types of measurements we use in our daily lives. Joule is used in measuring energy, Newton is used to measure force, watt to measure power, ampere to measure current, kilometres to measure distance, volume to measure liquid. To measure our phenomenon, we use a Richter scale, which was developed by Charles F. Richter. Our phenomenon is usually caused by a rock underground which suddenly breaks along a fault. This suddenly releases energy which causes seismic waves that make the ground shake. A person who studies this phenomenon is known as a seismologist. The phenomenon can cause after effects such as landslides and tsunamis. The third largest phenomenon in the history, which happened in Indonesia, December the 26, 2004, and the magnitude was about 9.0. Our phenomenon happened off the west coast of Indonesia island of Sumatra, and it lasted for about 10 minutes. Our phenomenon is the Indonesian earthquake. Congratulations, you have successfully completed the battle phase of your mission. Please place your findings in your journal. Now to move on to phase 2 of your mission, the experimental stage. You will be given a foam piece that you can cut into any shape. Your next step will be to break your shape down the middle. In your journal, write down what you think will happen to the foam piece if you were to start pushing the pieces together. On a smooth table, place both pieces of rubber foam down. You then place the rough edges of your foam together and start pushing the two pieces together lightly. Push one piece away from you along the tabletop whilst pulling the other piece towards yourself. See how they stick? Keep pushing and pulling smoothly. As soon as a little bit of foam rubber along the crack, the fault, will break and the two pieces will then slip past each other, and in that instant the earthquake has happened along a strike-slip fault. Final phase. To move on to the final phase of your mission, earthquakes can cause loss of life and millions of dollars of damage within the community. Surface waves and body waves from earthquakes can cause walls to crack, which moves and even crumbles entire buildings. Engineers strive to make buildings stronger to resist the force of earthquakes. So your mission is to take on the role of a trainee engineer and design a building using shapes, measurements and resources provided to you to construct a building that will withstand a mini earthquake. Trainee engineers. You will each need 30 toothpicks, 30 miniature marshmallows, earthquake journal. There will be 8.5 inch square disposable baking dishes filled with set jelly for the whole class to share. You can make large and small cubes and triangles by using full-size toothpicks and broken down toothpicks. Your buildings must be at least 2 toothpick level high and contain a triangle and a square. Once you have constructed your building, you are then able to place your building onto the jelly and shake the tray back and forth to simulate secondary waves. Within your journal, you are to record your findings through covering what shapes you used and how many toothpicks. And record what you think you can do to make your structure stronger. Why you think your structure toppled. Should you try making the base bigger or should you try making the building taller or shorter? You are able to rebuild as many times as the period will allow. Once you are happy with your design, then you are to draw and label the shapes in your design, cube, triangle, rectangle, and measure the width, length, and height of your building and calculate the volume using the equation volume equals length times width times height. Here is an example I did earlier for the volume of a rectangular prism. Well done, junior mathematicians. You have successfully completed our mission.